and I'll just set the timer whenever you're ready.
Okay, we're ready to go. Well, as was said, my name is David Black, and I'm a high school science teacher at New Haven School in Spanish Fork, Utah. And our team has been part of a research project called XMASS, which is exploring the moon and asteroids with secondary students. I have with me two of my students who will help talk about our results here. Our mentor teacher through this program is Dr. Michelle Kirchhoff from the Southwest Research Institute. And our project is to look at how we can take 3D altitude data from the LOLA instrument on the lunar orbiting Lunar Reconnaissance Orbiter and turn it into 3D models and then map some mineralogical data on top of it. So some of the minerals that we looked at were mostly from the M3 instrument on Chandrayaan. And the minerals include helium-3, titanium, thorium, and others. And we're looking to see if we can determine whether these minerals might be commercially viable for lunar mining. So I'm going to turn this over to Paige Williams and also Julia Walsh to talk about our results.
Hi, I'm Julia. When we mapped photographs of the moon over our 3D model of Clavius crater, along with the path that the SOFIA telescope took, we can see that water ice discovered by the forecast instrument may originate from a ray blasted out of Tycho crater.
So when we were deciding on sites for in situ research on the moon, we would suggest the areas of Aristarchus crater and Schroeder's Valley. Not only does it suggest interesting lava tubes, contain interesting lava tubes and brills, but deposits of lunar anorthosite, the original bedrock of the moon, have been uncovered in Aristarchus, along with high levels of thorium. Retrieving samples would allow us to date the age of the moon in this region.
Titanium dioxide and helium-3 are found in the Olda Maria basins along the equator in Mare Tranquillitatis and the southern edge of Mare Serenitatis. Younger craters such as Theophilus are relatively low in helium-3. Looking at the probable costs of lunar mining and the local abundances of valuable minerals, we were able to conclude that lunar mining can be commercially viable.
As you can see from the images that we have here, we basically took maps that have already been created in the literature that we found and then mapped it over the surface of our 3D models and then used some Photoshop puppet distortion filters to get the data to match up. As you can see here in the picture of Aristarchus crater, the blue inside the crater represents lunar anorthosite, which would be very useful, as Julia said, for us to be able to see the age of the bedrock in this region. On the map on the right, the dark brown areas indicate high levels of titanium oxide. And
sorry to press you, we're slightly out of time. We should probably move on.
Okay, all right, sorry.
But that's quite all right. But yes, but your poster will be there tomorrow, won't it, during the session, if people want to find out a bit more.